Thank you for having me. I'm a scientist, I'm also a consultant, and I'm a co-founder of Accents. So the sort of science I do is really studying how humans are using technology and what it means for their experience of using technology. And over the last 10 years, I've been mostly focusing my research and interest in AR and VR. So today I'll be sharing with you what I've learned and what I've uncovered in terms of the latest human-computer interaction science. What do we know about the experiences we're creating with those AR, VR setup, so that when we design those experiences, we're informed by science. We all know that to design technology that is being used, you have to use a user-centered design and know your user and their needs and their pain point and how they behave in order to design the right system. But as well as doing a user-centered design, you also need to know what do we know about the experience of users when they use this technology? What effect it has on their experience beyond just performance. So today I'm sharing this with you with the hope that this community can start using the outcome of science in designing their technology. So I'm starting my slides with work that Steve Feiner did about over 20 years ago at British Columbia, Columbia University, and he was the very first scientist who stated the value proposition of AR. And what he did, and this is early 80s, right? So it's nothing new. This has been extensively studied. He compared instruction given to an operator on a piece of paper versus having the information that they need on their field of view. And he was able to demonstrate very clearly that there was a significant improvement in the time on task, but also an improvement in reduction in errors. So this is work that took place over 20 years ago. Of course, at that time, the headsets were super bulky, as you could see. But this was basically the value proposition of AR. This is what AR can offer. And it does intuitively make sense because you increase the cognitive load of your operator if they need to read the information somewhere and then do the task that they're asked to perform in another place. And AR provides you that merging of these two spaces that allows you to do this in a similar manner, reduces the cognitive load and reduces the errors. And you'll hear a lot of talks today about that sort of value proposition, but remember this was actually studied in a lab context as well as in the field and established clearly. So we know of other industries out there that are currently using this same approach to use picking, using vision-based picking to have and reporting 25% increase in productivity. So this is really mostly doing localization, which is to help the person identify the place they need to go, as well as the specific object they need to pick. And DHL apparently is using some form of smart glasses in their shop floor. Yeah, and Boeing is an interesting beast for me because later on I'll show you about some of the work that I did with research collaborators for them. But they are actually actively looking at using AR in manufacturing and training for the wiring harness assembly, and they were reporting a 25% cut in production time and again reduced error. Apparently they also are now envisaging using AR out of space. So basically they'll have the astronaut, they'll be trained to do some basic maintenance procedure, and then they will augment them once they go out of space to do some more complex repair. But this would be using some pre-recorded video for instructions and so forth. So, sorry, I'm going to go back. This is well and good. It's mostly about information that is displayed in the line of sight. And it works very well when the problem is extremely well defined and we know the solution to solve the problem, or you have very well known procedures that you need to follow step by step, And that's where AR has been used mostly. Another use case scenario that is quite common, especially in this community, is when, well, the data and information is not enough. You are dealing with a very complex problem and you need to have a specialist who has a know-how, who can help you, guide you, help you troubleshoot the problem, identify what is the real problem, and then take you through the solutioning. So that's the remote expert solution, and we've heard many, many people working on this. I'm going to showcase to you a little video that presents a system that we developed with VR media for Boeing, and it's along the line of a number of systems that are being used here. Remote technology is a technology that allows remote expert to assist in real time a field worker anywhere, anytime. All you need is an internet connection.
That's it.
So instead of calling the expert and trying to get their assistance over the phone, or instead of flying in the expert, and that costs a lot to remote operation, you click a button and you have instant communication with your specialist. You're able to demonstrate with your hand what needs to be done. You know, what particular way you need to turn, for example, a knob.
Can you please use your touch to show me the side of the machine? There should be 3 connectors there. Can you reach it with the touch? I need you to disconnect the leftmost connector there. And can you put it on this one? Okay, yes. Good.
We initially designed it for the mining industry, but we also have a different form factor that allows you to just have a head-mounted system that you can adjust the way you want it, whether you're wearing prescription glasses, safety glasses, or whatever.
The worker is seeing the hand gesture of the expert, but also the expert can show some technical documents that are relevant to the workspace and do annotation on top of those documents. The technology that we developed doesn't need any training. Both the expert and the worker has audio headset, so they are able to speak to each other in real time. We have added a torch-like device to the worker unit. In addition to the camera in the torch, we have added a scanner so that the worker can use the tags in the workspace to retrieve information like technical documents, manuals, or instructional videos.
There is a wide range of application for this technology, and the industry that would benefit from it include health, transport, mining, shipping.
We see tremendous value in using the remote guidance systems for manufacturing and assembly, training, maintenance, and emergency repair. With the remote guidance system, a single expert can assist multiple operators located at geographic separate locations.
All aspects of the network communication are secure. The connection, the communication between the expert and worker, and the data.
CSIRO has customized the systems to our needs, enabling us to view technical drawings and record the interaction between the expert and the operator.
It's important to have this recording feature so that the field worker, after being assisted by a specialist, can revisit the interaction that they had with the specialist. Second of all, it's important for the specialist because then they have a record of what has taken place. Instead of flying in the expert, and that costs a lot to remote operation, you have that expert when you need it, real time. It's like having that specialist with you in the room, in front of the machine. So with the VR media, we won the State Innovation Award for this work because we were able to develop the prototype very quickly within 3 months, and then had the proof of concept, and then basically did a field trial at Boeing site to actually really uncover what were the issues, what tailoring needed to take place in order for them to adopt the technology. So the purpose of my talk today is really more about how we went through this journey and what we have learned, and what other things I can share with you from that journey from a scientific perspective. So we were interested from day one to actually build a solution for industrial use. This was like one of our main driver. I was working with a startup called VR Media that had a lot of expertise in building real product for industrial use. So we were bringing that expertise to bear. It has to be scalable, it has to be reliable, and it has to be super easy to set up. We turn up at Boeing site, and we're able to set up the system within less than an hour. The other thing was really having a design that is based on solid research. I was working at CSIRO then as a scientist in human-computer interaction. We wanted to make sure that we had a solid base in terms of the way we're supporting the collaboration, but also in terms of support for mobility. So we knew that once this system would be used, they would be used in an environment where there are lots of people walking around and equipment and machine, and we wanted to make sure that we would look at safety issues and spatial awareness, and that we would embed that as part of the design process. So you see what I can see is the normal thing, but this was actually developed and identified by Clark and Bremen in '91, saying the importance of of the shared video space to build common ground. So we do see the same thing. The other thing that was extremely important and was critical to our research was that we wanted to have the most natural interaction. We've heard today about the NUI and the importance of using your own body for interacting. There's a scientific evidence behind why using unmediated hand, that means hand without any controller, is more powerful than using a sketch-based or a pen-based or cursor pointer. For the reason that we've been built to communicate with our hand and to demonstrate not only what needs to be done, but how to do it with our hand. So why not bringing that powerful way of communicating in the way we design our interaction? And there's evidence that studies that have been conducted in the US and by myself and my team in Australia, as well as in England, that showed that when you use your own hand in a remote guidance scenario, you're not only improving the task performance, but you're actually improving other aspects of the user experience, like the quality of interaction, the way you feel connected with the person you collaborate with, the co-presence, the extent to which the person you're helping is feeling your sense of presence. They feel the sense of presence via the hands, and the hands are a very good proxy to the human. But also, of course, grounding, because once you point to an object, there is that resolve any issues. So there is sorry. So one of the things that we heard also from our operators when we were presenting this product is, well, how about having something more a remote collaboration or a tool that will give us a spatial understanding, because quite a lot of the things that were done in the context of a space where you have to relate the object one to another and be able to also assist and guide in 3D. So with the same collaborator that you could see on the right-hand side, his name is Franco Tecchia, and he's actually with us in the room today. We built again this second prototype, and I'll see if the video is gonna work. Can we lower the volume, please? So this one uses a Kinect camera here to do the hands acquisition of the expert, and another Kinect camera that does the real-time, 3D real-time acquisition of the place where I'm working, and here we're just doing a demo with doing an assembly task with Lego toys. And what we're doing here in real time is co-locating the hand of the person assisting me in my own workspace. So there's two benefits to this. First is that the remote expert is able to change their point of view, because suddenly they are seeing my scene in 3D, and they're not forced to just follow exactly what I'm seeing, which is when I had the camera on my head. So giving that ability to the expert to do what normally an instructor would do, would be looking around, changing the point of view to have a better perception of the space. Not only this, but Franco is also able to guide me in 3D. That means he's able to point in between objects, and suddenly he's behaving as if he's totally co-located with me. And that's quite powerful. This morning, we heard about the importance of embodied interaction. There was a very, very strong sense of embodiment. I really had felt that my hands were his hands, and I was taken through a procedure. So you can think of some application for training and surgery and so forth. What have we learned from this? Definitely that there were some improved spatial understanding, because the moment you give control to the operator and allow them to change their point of view and their perspective, they have a better sense of distances between objects and so forth. Definitely that embodied experience had an enormous impact on the sense of co-presence. As a matter of fact, I remember being sitting like this, and I could not tell the difference between the body of the partner, my collaborator, versus mine. So it's actually quite a weird one. And the third one is really having this gesture in 3D. Again, our brain is wired to compute much better the space that is around our hands. And suddenly you put the hands of the person in that space you're interacting with. It makes quite a lot of sense. It's natural, and it's actually also more natural for our brain to compute. So it improves the collaboration. It makes things like as if you are co-located, and that's the way to go with those type of interfaces. If you're interested in the studies, you can Google me, and you'll see a lot of publications where we report this. So this is another little study we did with the PhD students. And here what we decided is to give agency to our operators. So yes, when you do remote collaboration in 3D, you're able to bring the hands in real time to actually see clearly what needs to be done. But what about if you can actually grab things and have agency and be able to navigate in that space with your body, but also grab things in the most natural way? And in order to allow this, we built a collaborative augmented virtual reality prototype, and in which we have a Kinect camera that is just on the head of each of the partners. And we 3D printed the support and put an Oculus Rift and build this collaborative game. And I'll show you the sort of interaction you're able to have if this works. So we're tracking the fingers, and we're allowing people to actually grab those objects and work together. And they are in two different rooms. And the representation in that virtual space is actually mostly the head and the hands. And the hands, again, are important not only to be able to grab, but it actually shows your intention, right? The orientation of your head and what you do with your hand is actually quite a good proxy of what you're intending to do, and that supports awareness. You are with someone else, and you feel like you're aware of what they are intending to do, and you're preempting some of their actions. And you hear all of the interaction is in Italian because the students is Italian from Scuola Superiore Santa Ana. And we had a good fun doing this piece of work together. So here, it's not just grabbing, but there are instances, I'm not sure if we're going to see it in this video, where people are moving around this virtual table and grabbing other objects and walking through each other's steps, footpath and so forth. So the students actually looked at the space being used by people and to what extent they actually navigated in that space and interacted as if they were in front of a table. And also we looked at the extent to which each other's respected the space. So they were not bumping into each other. There was sufficient awareness that, how am I doing with the time? Yeah, okay, I'm gonna quickly follow. So these are some of the findings we found in terms of the social interaction that was significantly improved, enhanced agency, and that comes from that sense of embodiment. And we also looked at game engagement and flow, and we're able to report some significant improvement in that flow experience. So what I'm trying to say here is that if you're going to create those experiences, it's not just about the merging of the digital and the physical space. It's beyond that. It's actually creating a space in which you are interacting, and you're enabling a very rich interaction because you're using your own body to navigate and your own hands to do things like you would do if you were in a physical space. And it's the combination, the convergence of all of those technologies that is allowing you to create those quite unique experiences. It's not just the VR or the the MR aspect. So leveraging this HCI research means that we need to design for spatial awareness and understand how our brain works in terms of making sense of space, and use this when we create our spatial computing experiences. Agency is extremely important, so we need to think about interaction that is beyond just visual, but also doing things, manipulation, and there's neuroscience evidence that when you are manipulating with your own hand, it actually triggers your thinking. When you think while you walk and do things, you actually think more clearly. And this is where we're going with this spatial computing, is creating those interactive 3D spaces where you're allowed to use the clever thing about human that we are slightly uncovering with science. So where next? So we talked about the importance of spatial and the fact that the spatial computing is going to be fully integrated. I think the other thing, and Gardner, the lady from Gardner this morning were alluding to this, is, and that's a very strong interest of mine, is to say, well, as we are uncovering more things about what it is to be human and how we process things, the next wave of computing is going to take into account more and more things that we're going to learn real time about our own mental states, our own cognitive load, our own emotion, our own stress, as a way to offload some of these things and allow us to have a more enjoyable experience. And that learning will be evolving as we evolve as well. If you're interested in some of the books that we've been editing in this space with a group of scientists, these are some of the books. And thank you very much.
Thank you.